All right. Happy Saturday, everyone. Hope everybody's getting wrapped up for the holidays. All right. Brought myself some coffee. Delicious. What shall we do today? What do we have? Let's look at, you know what? I am so tempted, so very tempted to work on that DaVinci Resolve issue. So tempted. Maybe sometime this week. We'll see if the urge persists. All right. So, where were we? We were working on our new stack. This is the reverb stack. Inside of it, we have SQLite replication going from one machine to the next using a VFS plugin, an archive server that is just called data archive. We will be using TiKV as the storage for that. At the moment, we are looking at this piece of software and building it out, data archive. So that's a little bit of context. It would receive pages of data from the SQLite database. SQLite database stores, I don't know, its data in what they call pages. And by default, it's 4 kilobytes. We replicate those, store them, and send them out. So if a machine comes online, we can send the full database at a point in time. We could probably build some sort of interface so you could download the database at any given point in time, and so on and so forth. Coffee time. All right, to the code. Ba-ba-ba. Where is the code? Here's the code. All right. Now, we're driving this software forward by writing tests. Recently, I was unhappy with how the tests looked. I would rather use more context, like from the RS test. It just seemed like a lot of the tests had a lot of setup in order to get to the actual testing. So I'm looking to extract some of that into these, what do we call them again? Fixtures. We call them fixtures. So the plan is to be able to create a database or multiple databases and have a test context with like a 3 database test context or a empty test context. It's kind of like this one. It's just brand new. We should probably rename that. So I recently, I don't remember when, extracted out a utility crate. Let's keep going. Sorry, I'm just looking at the stream health. Slightly distracted. Right. Because last stream, the YouTube stream stopped a couple minutes in. So we're a couple minutes in now. I don't know what happened yesterday. Oh, shoot. How about now? I think I had. Oh, thank you for mentioning that. Thank you, Alordy. I had inadvertently turned the volume. Somehow I did that. I'm not sure how. But what I was saying is, I don't like this test the way it is. It's hard to follow. Um, sure, it says we're testing about getting the database information, but it's tough to kind of follow through. There's a lot of setup. I think if we had some consistent state ahead of time, like the three body three body problem, no, the three database problem, um, and just changed it a little bit, it would be okay. And we could break this down into multiple pieces to have a more descriptive set of tests. All right, let's focus on the first one. We'll break this down into smaller pieces, make it so we can reason through it better. And we will go with a 3 DB test context. We probably should have some sort of list of which databases are available. So we might modify test context just so that the tests don't have to query in order to know which databases are available. Or we just set up some static data and some consts here. All right. How do we set up a database? We have little test lib create testdb. We give it a path. It will create a database. Bunch of values. Create 10 notes into a database. Yeah, I see places we can update this. It would be nice to be able to pass in this value. Nice having the consistent seed. That's good. Okay. Great test DB. We have to give it a context though. Interesting. Where do we want this? tc.tempter or a directory under tempter? It should probably be a location under tempter. Now let's just use tempter. I forgot to check. Import that. Yep. Does this return an error? No, it just doesn't. Okay. No errors. Expected reference, found reference. Call path. Great. So that's one. And maybe we will have some other sort of function, but we need to record this. What should we call this one? Let's call it happy. Just to be consistent with some of the other tests. Oh no, and fun. Oh, you know what? There isn't a file name here. This is just a directory. Okay, we'll have to change that. Happy DB, we need a path for that. Dot, is there a concat? Join. All right. What does it? It doesn't return anything. It's one argument, but zero were supplied. Lies. All right. So we'll have oh no and fun. So we have 3 created test databases. So triplet, we have yet to put them into our test context. I feel like this pattern should be extracted into some function on the test context that's like create database. Let's do that. Async function, create database. Sure, we'll take DB name. That seems to be consistent. Rename that to just DB. Pass the name in here. Okay. So we call create tc.create database. Oops. Happy. Oh no, and fun. Great. Ah, liking it already. We have to await it to unwrap it. Okay, so we've created a test database by that name, but now we need to load the information into sled or TiKV. In this case, it would be sled. So what shall we do with sled? We have some functions already, but we should use the ones off of this archive object. So we get set database state, set database info, set database page. We'll be using those in order to populate our database. So we have a self.archive to get access to that. So set database info, the shard is going to be the same as the others. Self.shard, the DB name, and the page size, it just happens to be 2u32.pow12, because that's the default in SQLite. You know what? We don't have to unwrap here. If we bubble that error up to the test, it will help us figure out which tests are failing and where. Okay, so we set the database info, self.archive, set database state, shard, self.shard, database name, checksum. Ooh, we don't have a checksum or a transaction ID. Now, transaction IDs would really be useful only when data is coming in from data plane. So data plane would send information over to data archive, and given some information, we would create something that looks like a transaction ID. We have some text on what our transaction IDs should look like, a whole bunch of ideation, and we basically came up with one. Okay. Now, this information here actually comes from the wall log that will be used for replicating the data from one system to the other. In order to monitor changes, our VFS here inspects data that's about to be written to the wall log. That's a write-ahead log for databases. Now, we won't have this information. So we could come up with an epoch, fine. Salt, we could just come up with one, just make one. And the I change, that's a value out of the log as well. These could just be zeros, as it's very, very unlikely to hit that. Salt1 is a random number and increases over time. And I change, I forget what that one was. Oh, it's a counter that increases with each transaction. Okay. All right, so we basically need something that looks like that. These are fixed sizes, 8 bytes, 4 bytes, 4 bytes. So let transaction ID equals, and what does this expect? It expects it as a stir. I don't think that's correct. It should be like a vector or something like that. Where do we use that? Here? I think if we change that there, does this expected string found vector view 8s, database state, transaction ID. I think this is more accurate. Because it wouldn't be represented by a string very well. Okay, close that. Still seems happy. What errors did that cause? Click there. Ah, here we go. set database state. This is just a pass through on our test context to automatically provide things like the shard, transaction ID, wait. Oh, now we have 8 errors because of the tests. Okay, let's ignore those for now. Coming back to the test context, go back into create database. Now we have our transaction ID that we want to come up with and our checksum. We do have DB checksum. That's just a checksum. Okay, we want, was it here or here? I think it's here. Yeah, we give a path. And get a checksum of databases. How accurate do we need this? I don't know, but it should probably be as accurate as it can be. Do we use DB checksum yet? No. Pull that in. And where's our path? It's actually tempter. Ooh. Okay. We'll see. And here we can say get the database. This is relative DB path. Yes. Okay, so it would be relative to the base path, which is here. So really it's just DB name. Can that go into that? What do we have? Oh, it needs to be a path. Okay. Does that work? Or do I need a from? All right. So we get our DB, potentially. We get an option back. Okay. Let's just unwrap that. It should be there. And what we are expecting back is a dash map. Why is it a dash map? DBs. Add, remove, hash. What does new not hash them? It doesn't. Okay, so we have to call hash. Oops. gives us unit back, checksums the databases. Why do I not see how to get the checksum? Checksums here. We want the rolling checksum. So DBs, we just get DB. What returns a... Oh, here, create database returns one. Well, that's not useful. Well, I guess it is. It creates a new DB and inserts it. Okay, it's pretty blank. Add database, no. Well, that technically, there, right there is the checksum. Oh, it's a dash map reference to a DB. Got it. So we ask it to hash or checksum hash DBs, and then we get the option to the fast map hash. Got it. Got it. Got it. Okay. Where were we? In replicate. No, we were in context. Hash DBs. As we add DBs to this, this will do more and more work. Because it will list the databases in the path, checksum them. We could just call add database, which does checksumming and returns it to us. So let's do that. Add database, relative path is, what does it want here? Okay. Could we do from DB name here? Path is like a reference, and I was hoping it could reference that string, but no dice. Okay, but from this, we get back a result with U32. Let's call this DBs. All right, there's our checksum. Transaction ID. And is deleted as false. We need a timestamp as 8 bytes. And then we need zeros for the rest of it. So we want a vector of 0u8, and we want 16 of them. Okay, this here gives us the last two, the salt and the I change. Those 4 bytes each are zeros, which is okay. We talked about that. But then we want epoch as a U64. So let's overwrite those first bytes. Or we could just put them in here, couldn't we? No. The macro here would have to be explicit with all of them. How do we get the current time in data, in bytes? Standard time instant? Oh, that's 0. That's fine. Measurement, okay. That's for doing differences. System time. I see that it'll give us a system time object. I think this is the first time I'm actually using it. So what is a system time? Oh, standard. It's not monotonic. Okay, yep. By calculating the duration from this fixed point in time. System time now. Duration. So we have elapsed. So we could use duration since this one. And duration would give us, well, that would give us a duration, and then can we convert that to seconds? Probably as seconds. Oh, F64. No, we don't want partial seconds. Okay, and that gives us a U64. Perfect. Is there an easier way to get to that? System time now dot duration since. Oh, Unix epoch. A result. Let's unwrap that as seconds. Okay, there's our epic epoch. Okay. this as bytes. Set duration as seconds gives us a U64, a U64. We want basically I want the opposite of this. There we go. 2 LE bytes. I think we want big endian, don't we? Yep. Okay. So at this point, we could just reference them here. Let's see. We could do something like epic bytes 0, right? 1. Let's just do that. Be quick. If I get it right. 4, 5, 7. All right. 1, 2, 3, 4, 5, 6, 7, 8. Okay, there's our transaction ID. And is deleted. Oh, cannot find. Oh, is deleted. Lovely. Now, set database state. Does this return an error? Result error? It does. You know what? I don't want to return create error here. I want to return box 9 standard error. Because I want these unwraps to get bubbled up. Needs to be awaited. Okay, so we set the database state. And that's done. We add the database, set the database state. We need to set the database info, which is also done. I'm going to move that down here. State info. We need to set the database pages. Set database page. Now, how do we want to do this? We want to loop over 4 kilobyte chunks of data. Where do I do this? I know I do this already. Now let's just do it again. Standard file system. Let's just read it into memory. I'll read that. Our path is It's not a very good name. DB path. There we go. So we read that, unwrap it, and we are left with DB bytes. Okay. Now we want to loop over them in 4K chunks. Is that 4? Let's see. Let's call it a DB page. Dot. Yeah, we have a vector of bytes here. We have chunk by chunks. They do not overlap. And the size is 2. Same size. Okay. Oh, it wants usize. Fine. So what do we have here? We have a 4K chunk of that data. DB page data. All right. Arguments to this method are incorrect. Sure. I agree. Self.shard, DB name, checksum. Ooh, this is checksum of the page. So here, I actually want this. Oh, goodness. Okay. We need to get the database getDB here. Okay. Relative path. This returns us an option though. Okay. Is this DB checksum supposed to be? This is the checksum of the database at this point in time, not the page. Okay. So that's a mistake there. Because we do have the DB checksum. That was here. Let's rename that. DB page. Which number is it? Let's enumerate these. We'll have the page data, transaction ID. It's already set. Is the type wrong? Yes, it's a str. Okay. And the page data itself. Expected a vector found slice. For the test, expected found unit. What? Which one is unit? The transaction ID or to owned? No, that returns a vector. All right. Not seeing it. Expected unit found future. Oh. Hmm. Which one of these is a future? This is async. Await. Okay, transaction ID. Let's give it that reference that it wants. Okay. So now we have the database all paged in. Nice. Create the database, some random data in it. Transaction ID looks accurate. I wanted to check something with sled though. Tree and sled. Okay, no sled. Where was it? Let's go back to tree. Implementations, okay. Transaction, nope. We want range. It doesn't talk about, where does it talk about that? How it scans the keys. Okay, I think we're doing it correctly. All right, so now coming back to our tests and replicate, we can call create database 3 different times. We have 3 different databases created. And we can use a 3DB test context. Hey, thank you for the follows. Gomez, delongation of task. Delongation. Oh, goodness. I like that. Delongation of task. Oh, sorry, it's delegation. Oh my goodness. Words are hard. I like that too. Oh, thank you for the follows. All right. So we have this new test context. Now let's see if we can deconstruct some of our other tests into happier tests using this. So what are we actually testing here? Right? Get databases. That's all we have. We have some notes. Set the database state. We call get databases, and we see that one exists. Well, why don't we do that with the 3DB tests? Then we don't have the setup. We just call this and check the results. So much nicer. Of course, there will be 3 databases. Fine. We could then have another test for ensuring that only 2 have only 2 show up if we have one marked as deleted. Okay, I like this. Let's do that. So we're going to yank. Whoa, 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 whoa. Go back, go back, go back. 3 YY. There we go. There's the end of our test. There's the beginning of our new test. That's something else. Okay, we'll get to that. Let's clean this up. We have our test context. We want our fancy new 3dB test context. Now, this is what I was saying before, in that this list doesn't exist. Right? And it would be nice to have this information, let's say on test context or available in test context. Test context. Do we want the name of the three? No, because the name is actually coming from up here. These are the names. So why don't we make that part of this area? Static, happy DB. Okay. Same thing with, oh no, and fun. Oops. Okay, now we can use these. Happy, oh no, and fun. Hmm. Does this have to be like that? Or can I just, oh, okay. Happy. And then we would have, oh no, and fun. Oh, that might be in the wrong order though. I think fun would be first. I think it's going to give them back in the order that it scanned them. And the scan is going to be more or less alphabetic. Thank you, ASCII. Okay. So I like that. Test get databases, nice and concise. Oh, shoot. It says test that there are no databases. Oh, no, that's not right. The comment's wrong. Okay. The three. Look at that. So easy to reason through that the comment got updated. All right. Now our test something. What is the first here? We want to check that a deleted database doesn't show up. Great. Just going to extract that into a new one. Test. Get databases hides deleted DBs. Fetch this information. kind of our boilerplate here. Wait, but we need to hide one of the databases. Okay, I like that. We'll do that. Call fetch. Fetch get databases. No method named that. Found for the future? Isn't this? Oh, I forgot. This needs to be the 3db, 3db. Otherwise, it's referring to something else. Okay. Into inner. And we would have happy and fun. Those should be the only two. Okay, we'll need to mark that still. So how do we mark it? Let's see. We call set database page or state. Set database state. Mm. Maybe we should call like a, instead of something like this, we should get the data and then set it back. I like that better. So we have create database. The async function. Mark. Database deleted. Or set. Toggle deleted? No. Okay, so we have our little framework there. Self.archive.get database state. Self.shard. And the name. Oh, we need to pass in the name. Okay. Await it. So now we have our state. It is a, oh, interesting. It's an option. It returns a result to an option. Got it. Okay. Let's unwrap that. So now we have our database state. State, it needs to be mutable. Is deleted equals is deleted. And then we set it. Self.archive.set database state. Shard db name. Oh, interesting. And just give it the existing object. state.checksum. I expect that this would actually change the transaction ID. Okay, going back to our tests, tc.set db deleted state, database name. We will give it, oh no, true. But it's such a nice test. Okay, and we have pieces we can reuse elsewhere. Test something, get database. What else do we have in here? Add a deleted database. We did that. Add another database so we see more than one in the result. Now that's already done. We have 3 now. We've been testing that. Okay. Test get database info. Now, this is basically what we're testing at this point is the requests made from this data plane to this data archive when it starts up in a brand new machine, right? Or a machine that maybe was turned off and has stale data. So it needs to know what databases are there. It also needs to know, tell me about this database, like tell me the information about it. Right? Is it deleted? Is there a checksum? Stuff like that. So, let's see. Let's use the 3db. Happy goes away. Okay. Test that there are no databases. Well, actually, I just screwed that up, didn't I? We want the no DB for that. This is not found. Okay. And this still goes away. Mm. Okay, there's happy. Happy doesn't exist because it's not in the test context. There's no database. We get that code back. Ooh, all right. Let's break this down. Start pulling information up. What are we doing? Test errors when only one of the keys exist. Ah, yes, this is a subtle thing. We're checking for edge cases here. Database state. Okay. So we have a DB name. We're looking for, let's say, happy, whatever. But we want to have deleted a specific key from the database. Well, from our DB. So in this case, we set the state without setting the info. if only info exists. So in this case, info exists, but the state doesn't. And then we make them both exist, and then there's a success. This piece at the end seems to be the easiest to pull out. Let's do that real quick. Because this is the simple, expected case. Let's grab this, paste that there. Okay, for a little setup. Now we'll grab the last piece of this. That goes here. We ask for, let's go for fun this time. Fun DB. Ah, this is going to be different because our DB checksum actually has data now. And how random is this? It shouldn't be all that random. It should be repeatable as long as we don't change the value here, the seed. So each time we create a database, it's going to be identical. Maybe that should be passed in. Because right now, fun, happy, and oh no are three identical databases, which isn't all that interesting. Let's see what it ends up being. So this will fail. We'll update this based on the result so we can detect if it changes in the future, but we should get a success here. That's important. Okay. What else do we have? We have our edge case tests. Okay, and we have three DBs now, so we could just delete one on one, delete the other on the other, and go from there. One of these. And I like these tests so much better now. I like RS test. Okay. Now, in this case, we actually need to do the opposite here. Where's our assertion? Here? Okay, here's our assertion. We fetch info. Let's do, oh no. But we need to modify, oh no, to remove state key. Test database info, get database info missing state. Okay. We'll basically have the same thing for missing info. Okay. How do we actually do that? What is the state key for this database? We need that. Okay. And the state key, we delete a key directly. I do not think we need to clone this. Okay. That should work. This is very similar with info key. Let's see if that's right. Okay, then we get an error for that, missing info. And all this goes away. It's hard to read because there's so much setup in it. And this is already gone. All right, done. Oh, so much better. Hey, Roasted DV. Thank you for the follow. I'm a little slow on those, but thank you. All right, we need to check that this is correct. Well, we know it's not correct. It would be absurd for it to be 0. We're down to 2 errors. Where are they? Looks like they're in lib. Ah, transaction IDs. Yes. Okay. So when we start to create these keys, this needs to be U8. Yes, and how do we format that? I think our easy use format is going to have to change. Our keys are going to have to be vectors of U8s. Okay. We can at least push this a little bit. Okay, we moved the errors at least. So now the errors are here. And I would like to format a vector. How do we put raw data either in a string and then take it to a vector? Or I guess we could push data into a vector. We'd say shard dot 2 bytes. This into bytes, this into bytes, blah, 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 blah. That seems rather, like I like how it reads now. You can kind of see what's going on. Maybe we could collect into a vector. So let's say we had something like shard has bytes. Then we need database page, this has bytes, because we need something consistent so that when we get to actually having bytes, this is hard to read as well. Okay. Database name. Now we need forbidden token. DB page. 2 BE bytes. Expect, yeah. So that's no. We want this, but we want it as. Let's see. Can I just take a reference to that? Yes. Okay. So now we have the page itself. That's the page number, and then transaction ID. Oh wait. Forbidden token, database name, forbidden token, DB page, forbidden token, and then transaction ID. Which happens to be bytes. Okay. Oh, interesting. Flatten it. I wonder, can I just change these to B bytes? We could say like, oh, this is bytes or something, right? Hmm. I kind of want to do that to all of them. If we remove the B, yeah. Okay, so it does need the B. Let's have fun. Here we go. All right. So all of these now return vectors. We no longer need as bytes on a bunch of these. Just the inputs, we need them as bytes. So that will help with readability. Oh, um, not too bad. Okay. Shard database name page. All right. I can see that. We could also have these as things that can go into bytes, except for the database page. We don't know what that's going to break yet. It's okay. So here we want char.as bytes, and then we want databases. Concat. And then we want DB name as bytes. Okay. This is almost the same thing as that, except we want DB info. This one, a little bit more involved. as bytes. Database checksum. I'll have the name as bytes. Forbidden token as a separator, and the DB checksum. Okay, good. One more. Oh, vector. Okay, now we have our all of those, and it only produced 5 errors in the rest of the code base. That's not bad. Oh, I'm not seeing where the error is in this file. Oh, here. Can I say? Oh, because key is now vector view weights. Bum, bum, bum. So this goes back to sled. No, slog. Where's value? Trait value. Function serialize. Value that can be serialized. Types that I've implemented. This type, okay. This is implemented for quite a few things, but not lists of things. Well, other than string. I guess unless we have Saturday value. Like sequences or structures. Interesting. So I think this is likely implemented for, or should be implemented for vectors of things, yeah. Implementers. There are no implementers. Oh, that makes me sad. Without an implementation of value for your type, you must emit using either the question mark, pound question mark. Well, what do these look like? Let's play around with that. Let's see, E front line. Let's say AOU colon pound. I don't know. I keep trying to save it. Oh, it's a macro, of course. Keep trying to save it. Not gonna work. Cannot be formatted. Okay. And what if it was some bytes? Say we had that followed by. We don't need the option. Still not gonna save. All right. That's not going to work because it's not. Oh, we're doing a vector of string. No, 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 no. We want this to be a vec of U8. And that means that this has to be dot as bytes. This, 2 big endian bytes. Cat or append. Append. Okay. It's different mutability. Expected mutable reference. Oh, interesting. Okay, fine. Is that what it's looking for? Found reference. And mute. Oh, maybe 2 back here because it was just a slice. Oh, 2 vec's not on string. What does it have? As slice. We could go to as bytes. Um, okay. Insert. As ASCII, as bytes. Bytes. Turns an iterator. I think we just go with as bytes. And then make it 2 owned. Oh, must invoke functions. Okay, good. The goal of this is just to see what the output looks like, see if it's reasonable for keys. Expected, yes. Immutable. Yes. No, we want a vector 2. Hey, okay. So that's with this formatting. Going back. Percent. What is percent? What is alternate? Hmm. Pretty. Display. Alternate display. Guess it doesn't have. Hmm. Which is better? A or B? Oops. Oh, how do we represent that here? Let's just go with the default. Let's say we want to have key here going into something. This won't work because it doesn't impl display. We could have our own type for key. Make this a bit easier to see. I kind of like that idea. Debugging is going to be critical for something like this. And I don't think that I want to get something like this and think, yes, let me get out my ASCII table and figure out which one of these it is, or build a little program that just converts these to ASCII real quick, or use the online one. I would rather it just be there, be available. So maybe we implement display or value rather or sled to be able to print these. Oh, not sled, slog. So how do we do this? Serializer emit. And what is record? I appreciate that they have documentation, but it doesn't talk about what the types are here. What is key? Opaque key is a representation of a key. Maybe that's the text here. Maybe it's that. And then what about record? One log record. Is that the whole line? Okay. I do not think we would need to use that or that. Just serializer. What does serializer have? Emit stir. Emit. Okay, we have different pieces here. Bool card. Emit U32 key. Interesting. So we could basically deconstruct our key information into something like this. I could get behind that. Having a stronger type for our different keys. What would that look like? Let's see if we come back. So basically, we want them to be able to go to this. But each one of these could be its own little type. A database scan, right? Just create a new type. Construct database scan has a, say, shard. We want these things to reference other things. We could have a lifetime here. Spur. Then we could impl this. Sure, create a new. Why not? Is there a trait in standard for? I don't think there is for going like a two vector things like that. Asref, no. Iterator. We could implement some iterator type. Okay. No. Oh, maybe this is 2 bytes. But 2 bytes kind of means something else here, doesn't it? We have in 2 bytes, which returns a vector. 2 bytes returns a slice. But the way that we are constructing these, it's kind of a halfway. So we don't want to consume self. So what about like a as bytes? That's a slice as well. Artinsky, thank you for the follow. And Fancy Yellow, thank you for the follow. What returns vec of U8? From into vec, okay. Into bytes. I don't want to use into. As mutable vector. No. Hmm. Let's just say to vec. Fine. And we already have that? Oh, this will be self.shard. And we will get rid of databases scan. Now over a little type there, get rid of that. We have to implement value for it. Simple value. We should qualify this as, oh, do we not have slog? This is from foundations. Telemetry? Log? Is it not re-exported? It is not. Well, that's a bummer. It would be nice to have it re-exported. So if we look at something like the error here, is this just re-exported? No, it's wrapping current log. Okay. Re-exports for macros. Oh, boo. Do they is that public? It's not public, is it? All right, so we then need to import slog for this. Okay, let's do that. Logger.toml. Let's add slog. PQRS. Okay, alphabetic. SLED. Slog equals star, because it's whatever Foundations is using. And then should make a note of that. Coming back to lib then. Wait, what's broken in context? I don't see anything. And here we need to use slog. Sled slog. Sled slog. Slog value for database scan. Did I put that in the wrong place? I did. It should be up here. There we go. Okay. And we need our lifetime. Good. Expected a type, found a trait. Oh, well, that's what serializer is this? Hub trait. That seems expected. We need to make that a serializer. It seems like it needs to be a generic type. Trace serializer. What is all this? Oh, sorry. I want value. Value, value. Let's see it implemented for string. Hmm. And why doesn't it care? Serializer. We have a trait. We have serialize. I think this is expected. Expect as a type found a trait. Any more info? Hmm. Let's use serializer dot emit stir. E would be, let's say it's going to be, what do we have? Shard. Shard. And value is self.shard. Well, I'm a little perplexed with this. I don't want to do a cargo check on it. Uh, so if we emit here, we could do one of those and emit again. Serializer, emit, foobar, whatever our thing is. Um, what would we want these to be called? These are our namespace. Emit stir namespace. And this is databases. So we have those two pieces of information emitted for this. Okay. Let's come back to this error. Oh, use a new generic type parameter constrained by da da da. See, this is what I was thinking it wanted. Hmm. Yeah. If we added S, serializer, just use that here. Oh, expected stir. Let's just say it's databases. Hmm. Now I'm rethinking the forbidden tokens. Maybe we shouldn't have them in these. Because I would like to be able to reuse this. Does this serializer have stir? Yes. Bool. Char. What are arguments is? Okay. Basically, we have to come back to it being represented as a string. Okay. What about S here? It's not constrained. Huh. So the type parameter S is not constrained by the impl trait, self-type, or predicate's unconstrained type parameter. We had before was serializer here. And it gave us a hint. What was this hint? Constrained by. Right, let's take a look. What is it saying? Serializer impl. Use a trait object to accept any. Isn't this what we're doing? Oh, no, we're not. Wait. Yeah, it's deprecated. Oh, slog, you are so old. It's a hard error in Rust 2021. Ooh. Hmm. All right. All right. So we got the dyn in there. Opaque type. Yeah, I mean, that works too. Oh, it has one type parameter. Really? Wait, what? Fine. Dyn it is. I wonder if that's what they intended before. In the previous version, excuse me, of slog in Rust 2015. That's before my Rust time. All right. These two unused. I had those. Hide the console. All right. Where is this used? I'm going to start to remove the forbidden tokens from it. Okay, is this the only place it's used? Oh, wait. I have a function for that. Oh, look. A couple of places. We're going to get rid of this one. So forbidden token, databases, forbidden token. Now we can get rid of them inside. And that means we can use that here. These, let's make them stirs and take them back 2 bytes. I know we're bouncing all over the place. Okay. Done. Okay, so this I think is what we will have for these. It's a little bit of work, but I think it's okay. Database state key. So this has that and the DB name in it. These should probably be in their own little module. It's starting to get a little, I don't know, a little busy here. Mod DB keys. Let's move all of those down to about there. Let's extract this into its own file. Give it a save. Many more errors now. That's okay. All right. Here we go. Now we have DB scan. I'm going to mutate this one for the next one because they're so similar. All we're doing is adding a DB name. What did we call it though? Database state key. Okay, boom, done. To vector. Now this one needs to follow this pattern. Forbidden token. And then we have the DB name. Now I noticed that in our DB state key, there are no forbidden bytes at the end. There probably should be. That might break things later. Mental note. Oh, no, no, we don't use this for scanning. This is the end of it. Okay. That's it. We have databases. And then that. Good. shard namespace and serializer. DB name is self.dbName. Okay. DB info key is actually just like that. But what else did we have? No, it's basically the same thing, just the key has changed. Okay, we can clean that up later. Namespace is now database info. Key is different. Done. Done. Right, so this one, like the previous ones, but now we have a third value and a second constant. Shard name and checksum. So db checksum namespace first. We also need to get the parameters right here. So we have shard database checksum. Oh, that was forbidden token. I did mess that up. Okay. DB name. Okay. No, but we want checksum DB name. Got it. Forbidden token again. And then DB checksum. Oh, what isn't it like this? So we have the shard, forbidden tokens, checksum, forbidden tokens, name, forbidden tokens, followed by checksum. I believe that checks out. This is surrounded by forbidden tokens. So 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Okay. Belt and suspenders. But here, namespace, we need to emit db checksum. Self.db checksum. And RU32. Good. All right, two more. They get a little bit more complex, don't they? Transaction ID. And what do we have for transaction ID? Shard, DB name, DB page. Oh, we should probably rename it real quick. Okay. Name, page, transaction ID. Let's just take those. Okay. Now for the 2vec piece. The shard, right, forbidden token. Now we need database transaction ID, forbidden token, the name. Okay, it's already there. Forbidden token. Now we're up to here. Now we need the big Indian bytes. Oops, I do not want to cut that. I want to copy it. One, two, three, four, five, six, seven, eight, nine. 1, 2, 3, 4, 5, 6, 7, 8, 9. Forbidden token is every other one. All right. Now here, shard namespace. Namespace is transaction ID. Did I update that? I did. Shard namespace name is there. I want page and transaction ID. What is transaction ID? That's oh, that's our bytes. Ooh. You have to parse the transaction ID here. U64. And this is the epoch. And this is self dot transaction ID. It's U64 from BE bytes. We give it a slice. What's this? 0 dot dot 8. It needs to own them. Okay. Well, goodness. We do that. No, wait. It's like it wants them on the stack. This isn't going to work. Want to copy these into some other set of bytes. There we go. Try into trait. Really? Interesting. Try into. Okay. Ah, well, that's why I do this. Learn something new today. One more new thing today. Try into on that. Okay. And there's two more. So at this point, we want a U32, and this would be salt 1. So U32 from 8 to 12. And salt, transaction ID. Sure. And then what's the last one? This would be 12 to 16. And what was the other part of transaction ID? It was some incrementer count. Was it? I change. Goodness. Okay. And if we decided to have a types that represented transaction ID, these could all move into transaction ID. Okay. That one is done. Oh, look, we have transaction ID again. I think it's time for a type for that. All right. Transaction ID. Oh, struct. Because we will actually need this over here when we are taking data from data plane and starting to insert it into the database. We'll want to take these three pieces of info, create some type, and then be able to use that. Epic. U64. We want salt. It's U32. And I change U32. Okay. That's fine and dandy. Derive. Come on, fingers, keep up. Debug. We probably also want copy clone as our copyable types. Okay. But now on DB keys, we want our toVec and to implement value. How about we generate a new function toVec. Hey, give me 2 minutes. 2 minutes, thank you. Okay, thank you. Thank you everyone for being so patient. I'm back. So let's do the same thing. We will have epoch dot to, oh, self dot epoch. Self dot, you know what? We like first C and just like, no, we need the byte ordering to be specific. Okay. Sorry, my C is showing. 2B bytes. That needs to be a reference. Great. We need to do that a couple more times. Self.salt 1.2 BE bytes. And I change. Expected an array with a fixed size of 8 elements, found one with 4 elements. Oh, interesting. This needs to be as there. Have to give it a type hint so that it knows that it's not a reference to that type. Wait, are these all 8? 32. Oh, I'm sorry, U8s. Yes, they are all U8s. Okay. So we have that. Let's add the value portion. DB keys. Basically take this and just, oops, too far. Copy, lib. Implement this for transaction ID. We do not have lifetimes for this yet. And we can get rid of those. Self dot, oh, we just say self dot epoch. Self dot salt. And self dot I change. There we go. Now here, database transaction ID, this can actually be a transaction ID. It's copyable. Okay. Extra allocation here. I want to do like an as bytes. No, I don't care enough. Not right now. Um, that's good. Be tiny. Okay. So now we have our vector. Good. It has a transaction ID. Now here, instead of these three, I think we can emit, or we can just call serializer on it, right? So we can say self dot transaction ID dot serialize and pass this information through. Record key serializer. Nice. Lovely. All right, and that'll make implementing excuse me, database page data key, because it also has a transaction ID. Okay. Let's copy all of this, give it a paste. Database page data. It sounds like it should be a key. And if that's a key, everything else should be a key. Not all of them. Key, 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 key. Okay. Now for this, we need the shard. Yes. Name. Yes. Transaction ID and page. They're just in a separate order. Okay. Oh, that's the new. We're fine there. To vector is different. So we want the shard, yes. Then forbidden token, page data, forbidden token, DB name, then transaction ID, and then database page. Okay. So those are swapped, so we can scan in a different way. Okay, that's good. And this goes away. All right, given that we've just created a bunch of types and we have 21 errors, let's go look and see what's broken. Wait, is there something in this file that's broken? It has a little red X there, but I do not see anything in the gutter. Oh, there it is. Barely off screen. As bytes. Okay, those are better. Let's start at the top. Database state key. Ah, yes. Database state key. Don't we have that? It's in DB keys. Oh, they're all private, aren't they? Yep. Hub. Hub. Couple more. Okay. Save it. There we go. Newest private. Doesn't feel like all of them. New, new. This one. All right. So here we want to convert this to, yes. And all of our two vectors are also private. Well, first one, um, is that all of them? Oh, missed one. Okay. To vector. Hey, one is done. Database state key. And okay, that's all right. Shard and DB name. What is it? Oh, it needs to be new. And get database state. Set database state. All right. Oh, look. And key works. Boom. It worked. Goodness, that was a long hour to get to the point where we could have key in the log. Shard DB name to vec. Right. New to vector and for key. Key is key. Oh, so much better. Our future self will love their past self because of this change. Set database page. Database checksum key. Database checksum key. New. To vector. Transaction ID key. New. And we need a transaction ID. Lovely. This should be transaction ID. Okay. Database page key. Page data key. I think that's what it is. No. Shard, DB name, page size, and then, okay. To vector. What is this? Batch delete. DB checksum key. These are all wrong. Okay, this should be dot to vec. This is in case something goes poorly, we want to delete what we just tried to do. Right. Database scan. Databases scan. This is for the key, right? Scan key. There we go. Oh, interesting. We need the length of this. Huh. Maybe let's add a length. Okay, so we have self.shard.length plus, let's just write it out full. We could combine the twos, but let's just keep it in sync with the other functions so it's obvious to other developers. Databases.length plus 2. Okay. Now we have our length. This here needs to be at a 2 vec. There's our range. Okay. Okay, that's good. Now we're down to 5 errors. We have context and replicate. Let's pop into replicate real quick. Where are the errors? Oops. That's not used. Hmm. There's probably just some errors going on. Let's not clean those up too much. Ah, forbidden token. Yes. This moved. Great. DB keys, forbidden token. Is that public? For the crate it is. Ah. What? Wait. What is it? It is now. Okay. Not something we can search for because this is just bytes. It's a static U8. It's not a stir. Let's make our lives easier. Forbidden token stir. Hopefully, with those things being right next to each other, they are kept in sync. 3 errors left. Any in this? Okay. Move all. It's unused. It's unused. I've not been very good about keeping on top of the warnings. So it's about time. Ah, yes. So in this case, we have little wrappers around these keys because the test context has the shard in it. So we'll have to change these. Where are these being used? Ah, yes. We use it to delete a DB key and replicate. in the tests of replicate. Okay. So for this one place, database state key, new, self.shard, and DB name. We return a database state key. It should be able to delete that. But we need, nope, no. These two actually have the same lifetime. Well, they don't. They might not. But if we say that they must have the same lifetime, I think Rust will solve for a lifetime that is the shortest. Not certain though. Same thing here. Okay. So in this case, we actually need a realistic transaction ID. And we created one by hand. This will be great. But we want epoch, and then 0 and 0. So we can get rid of those. That. Set database state should take a transaction ID. Let's use the types as long as we have them. Yeah, okay. The wrong type. Okay, we need serialize and deserialize for transaction ID. Done. So we just serialized it. Good. Last area, context. Let's go to the top. Transaction ID gets passed through. Great. Six errors. Back in replicate. All right. So now we have the key for this. Need to convert that into a vector. Great. Same thing here. Ah, no errors. We can actually run our test code. Ooh, big moment. Big moment. Cargo test. Data archive. No capture. Take a moment while it compiles. Almost there. Almost there. Anybody have weekend plans? Last minute shopping, anyone? I know what I'm going to be doing. Yeah. Wait, what's this? The tests passed? Did they pass? Zero, pass, zero, 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 zero. Wait, there are no tests being run here. Cargo test. Dash P. Oh, there it is. Okay. I was wondering why it was taking so long to build. That makes so much more sense now. Yep. X message. Always last minute shopping. Yeah, I have a little bit to do. All right, so we wait again. I was really excited when none of the tests failed, but one should fail because of the randomness. One should fail. Oh, we have some ordering changes. Oh, yeah, okay. Left and right. Not found internal. Okay. A couple of errors. Let's turn off no capture. Okay, good. Let's take a peek. So replicate. Oh, Okay, so sorry, little background stuff I got going on. Line 253, 253 here. Well, alphabetically, yes, those are not in the right order. Okay. Will that get us a little further? Just want to make sure that didn't. Four passed. All right. Good. We were at three before. Right. Get database info. Let's see. Test get database info. Red blah. Panicked at 287. Here. Calling unwrap on an error value. Fetch database info on fun. Interesting. Okay. So that's not working. I'll have to figure out why. Let's see if fixing one of the others helps. Maybe it's some of this. Right. Could not deserialize value for key. Found an option discriminant that wasn't 0 or 1. Database info. Oh, look at this. FunDB. Oh, I like this. Look at this. Failed to get FunDB. Could not serialize. Found an option discriminant that wasn't 0 or 1. Data archive 159. Where's lib? Name, database info key. Hmm. What does this mean? We are using postcard. Bad option. Found an option discriminant. Okay. Hmm. That because there wasn't data or back to the code. All right. Let's do just one test. Okay. Deserialization's not working. Great. 159. So value. Let's debug that here. dbg value and see what it is. Kind of curious what the key is coming out to. um, 128 and 2. That doesn't seem like enough data. What is what are we storing there? Get database info. Where's set database info? That's this. Value. Oh, we only have page size. Database info. It's a sum, so it comes in here. We do from bytes. It says from postcard. And it doesn't like it. Hmm. But we must have set it up here. Let's debug value. And the key. Why not? dbg key value. Oh, do we not implement derive debug? Let's toss this on all of them. Scan key, database state key, database info key, checksum key, transaction ID key. All right. I think this is going to get called many times because we're setting up the 3 DBs. At least the setting is, and then the getting would happen once. Shard happy, page size 4096. Test oh no, test fun. Yep, good. Okay. So then on 151, we do the get. We're testing for oh no. Okay. That should come out to be the same. Value is none. 158. Really? But we just set it. Database info. Too much, too much. Too past. Oh, how do we make it just this one? We don't want the regular expression. Want it exactly that. But it's doing both, which is why we're seeing so much more. Yeah, let's do this one, because this one's failing as well. Okay, just one failure. Insert, insert. So 3. Here's our get. We get nothing back. And it says it's an internal error instead of not found. That's not right. Oh, wait. No, it should be an internal error because the database was out of sync here. Let's go to 327. we replicate? So when we do a fetch database info, if we don't have one of the elements that we need, if the database is like out of sync, fetch database info, okay, that just passes through to the library function. Nope, no, not that one, not that one. This makes the request. And then in replicate, fetch database info. Hold on. We're calling fetch database info here. This gets called. So in this case, one of these should have been triggered. It would have been one of these cases here. There's an issue fetching information for blah. Lost no capture on there. Do we have any log info? No. Let's see what join result is. None, none. Wait. We shouldn't have gotten none back for both. UC Sailorman, thank you for the follow. Database info. Database state. Why would we get none for this? Because our test is deleting one, right? We delete a key. What key are we deleting? Where's that? 326. Where's 326? Okay, delete 326 is here. Database info key, test and ono.db3. So we did not delete. Hold on. Maybe this is because DB keys. Did I mess this up? Okay. So yeah. So DB scan key is databases. Good. DB state key is databases. I believe that's correct. DB info key has database info. Checksum. Checksum. Transaction. These all seem correct. Database page. Yeah, no, that I was hoping it was just some silly mistake here. Shard, forbidden databases. Okay. Because it would have been an issue between this one and the other. Like databases being the same in both places. Database info. God. Well, if it's not that, what is it? So we tell it to delete one thing, and then it looks this up, and it gets a nothing back, which I guess that's right. We're deleting nothing. We're deleting something, and then we get nothing back. The join result, though, is none, none, where we should have looked up two things. As fetch database info here looks up the state and the info, both turn option to a result, excuse me, a result to an option. So are we getting this could not find database? Yeah, we're getting not found when we should have received this internal because one of the databases was none. None, none. Oh, this is weird. This is so weird. Okay, let's go back to missing info. What do we get? Let's say we do this before we do the removal. It should be there. Right? Oh no.db3 exists. Hmm. Hey, Dev is fun. Thank you for the follow. All right, so first, yeah, there's our join result for none, none. Join result, bad option. Oh, okay. We got something going on. But I do have to do other things today. So let's call it. I appreciate y'all hanging out. It's always fun. Let's see. Who shall we raid today? Hmm. Seeing much rust. Oh, I'm going to choose a random. Here we go. Starting soon. Oh, are we coming up on the first bit of a stream? Okay, it's got some music. Oh, let's start a raid on the beginning of the thing. TJ Spears. All right, y'all. I gotta head out. I'll probably be doing quite a bit more streaming this holiday season. So, until next time, take care. Bye bye.